Alrighty, let's go on page 78 when we are finished. So this is properties of special parallelograms. So we talked about generic parallelograms, or anything that's a parallelogram has all of the properties that we have just talked about. Then we have some special ones that have some additional properties, okay? And so this, we'll start with a rectangle. So this is the definition. So by definition, a rectangle is a quadrilateral, okay? So it means got to have four sides. It's a quadrilateral with four right angles. Now, there's a lot more that you know about parallelograms. I'm sorry, about rectangles, right? And I know that. But that is what makes a rectangle a rectangle. The definition is what makes that thing what it is. If you see a picture that looks like this, that is a quadrilateral with four right angles, that is a rectangle. And of course, again, there's other properties that you know about it, but that's what's happening right there. Okay, we good with that? So let me ask you, just by this definition, is a square a rectangle? Yes, because a square is a quadrilateral with four right angles, right? If I have a square, the best name for it is not rectangle, but it is a rectangle. Does that make sense to you? It's just like an equilateral triangle is an isosceles triangle, right? It's, going into groups. Yeah, it's like part of the family, right? It's just a different, yeah. There you go, very good. Okay, so a rectangle is a quadrilateral with four right angles. So then we have, if a quadrilateral is a rectangle, so we know it's a rectangle. There it is right there, quadrilateral with four right angles. Here, are both pair of opposite angles congruent? This is not a hard question. Yes. This one's congruent to this one. This one's congruent to this one, right? So both pair of opposite angles are congruent, which means what does that have to be? Look at your notes from Friday. Parallelogram. If both pair of opposite angles are congruent, then it's a parallelogram, right? So if this is a rectangle, clearly both pair of opposite angles are congruent. So then if it's a rectangle, it is a parallelogram. So to abbreviate this, because all of these theorems I've abbreviated so you don't have to write all this mess out. If it is a rectangle, then it is a parallelogram. So Jacob asked a question about, oh, well, hey, a rectangle has opposite sides congruent, so does that mean that it's a parallelogram? And I said yes, but that's really not the way it works. The part about having opposite sides congruent, that is a parallelogram property. Does that make sense to you? It's not that since the rectangle has opposite sides congruent, that makes it's a parallelogram. It's because this is a parallelogram, that's why the opposite sides are congruent. Does that make sense to you? So it's still true, all in all. But so my conclusion from here then, if this is what I have, then I know that ABCD is a parallelogram. Okay. Then it says, if a parallelogram is a rectangle, then it's blank. All right, so I have the diagonals drawn in here, right? This is a parallelogram. We know that, right? Because a rectangle is a parallelogram. Then what's true about the diagonals of a parallelogram? They bisect each other, okay? So these two pieces are congruent, and these two pieces are congruent, right? That's true. We know that from a parallelogram. Now, we also know that if you have a parallelogram, then this diagonal bisects this into two congruent triangles, and that's true. But we're going to look at a couple of different triangles here. I want you to look at triangle ABD, that triangle right there, and not this one over here that's the other half of that. But I want you to look at ABC. And what can you tell me about my green and orange triangles? How are they related to each other? Not necessarily. We don't know anything about specific angle measures because this doesn't necessarily bisect the angle. It could, but this orange triangle and this green triangle, they're congruent. Can you tell me by what postulate or theorem? Like side, 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 angle, angle, HL. Okay, but that doesn't tell me about the triangles. Side, angle, side. Good. Because you've got this side, this angle, and this side congruent to this side, this angle, and that side. Does that make sense? Good. Yes, okay. Very good. So that we've got, so those two triangles are congruent. Since the triangles are congruent, isn't everything about them congruent? Then tell me about the diagonals of a rectangle. Doesn't the hypotenuse of each triangle make the diagonal of that rectangle? So do the hypotenuse of those two triangles have to be congruent to each other? So what's true about the diagonals of a rectangle? They're congruent. They bisect each other because it's a parallelogram. Does that make sense to you? That applies to any parallelogram ever. But then for a rectangle more specifically, because basically a parallelogram is kind of leaning, like if you straighten everything up, then that makes the diagonals congruent. So if a parallelogram is a rectangle, then its diagonals are congruent. So it's a rectangle, the diagonals are congruent. So that leads us to something else huge that is easy to miss sometimes. That isn't a theorem. It isn't even officially on a property list, but it can make you think you are stuck when you are not stuck. Okay, so since the diagonals are congruent and they bisect each other, then what can you tell me about each one of these little pieces? They're all congruent to each other, right? That's not how I have it labeled right now, but they are all congruent to each other. Would you agree with that? You take two things of the same length, cut them both in half, you get the same answer, right? So because of that, what kind of little triangles do I get here? Isosceles. And that's the part you want to not lose sight of, because you're going to get to some of these problems and you're going to think you don't have enough information, and you totally have enough information. Okay? Because in this rectangle, since I get isosceles triangles, do I have any congruent triangles here? Yeah, these two and these two, right? They're not all four congruent, but I do have two sets of the little ones. All right, so if I give you this angle right here and I say this angle is 20, if you don't recognize the fact that these are isosceles triangles, the only other thing you're going to be able to get is 70, right? But because it's isosceles, if this is 20, what's this? 20. Together that's 40, that makes this 140. And then if this is 20, this is 70, which means this is 70, which means I can get that angle. These are congruent, so they're both 20. So by giving you one little piece, you can fill them all in. Does that make sense? So it's actually really easy, but you can't do any of it if you don't see that you have isosceles triangles there. Does that make sense to you? And that's not what the theorems actually directly say. So what the theorem directly gives me here is that line segment BD is congruent to AC. Okay? That's what the theorem directly gives me. But because that's true along with the bisecting part, I have to put another letter in here to make this happen. We're going to call that point E. Then I know that line segment BE is congruent to line segment ED, which is congruent to line segment AE, which is congruent to line segment EC. Okay, and that's a lot of the letters, but. Okay. Everybody okay with that? All right, so that's rectangle. We good? So a rectangle has all the properties of a parallelogram plus these two. Well, really three, because you can't think about the part of the definition being a property. But all right, so now let's look at a rhombus, which is never, ever a diamond. So by definition, a rhombus is a quadrilateral. That means it has four sides with four congruent sides. That's what makes a rhombus a rhombus. So is a square a rhombus? Yes. A square is a quadrilateral with four congruent sides. Therefore, a square is a rhombus. Not the best name, but it does fit into that family. Okay? Yeah, exactly. A square is not only just a rectangle, it's also a rhombus. All right, so a rhombus kind of looks like a square that's been stepped on, kind of slanted, right? So this says if a quadrilateral is a rhombus, then it's a blank. All right, so all four sides are congruent. Are both pair of opposite sides congruent? This is one pair of opposite sides, they're congruent. These are congruent because everything's congruent, right? So if both pair of opposite sides are congruent, what does it have to be? A parallelogram. All right, so if it is a rhombus, then it is a parallelogram. So my conclusion here, A, B, C, D is a parallelogram. And just know that this is the symbol for parallelogram, but if that wasn't a problem and this is all I have, is that enough to say for sure it's a parallelogram? No. And I know that you have been trained to assume things, okay? That when you were in junior high school or even elementary school, that if you saw this and you didn't say square, you were wrong, right? You were supposed to look at that and go, oh, that's a square. And if you saw this, you were supposed to say, oh, that's a rectangle. And if you saw this, you were supposed to say, oh, that's a parallelogram. Doing that now makes my head want to explode, okay? Because that is so not right. You don't have enough information. And here's something else you have to remember. I'm not saying that this is not a square. What I'm saying is we don't have enough information to prove it, right? So it's not saying that it isn't. It's just you can't prove that it is based on the fact that it looks like it. If I did this, now can I say it's a square? No, because it could be a rectangle. Well, it is a rectangle, right? Rectangle is the best I can do. That's all I can really do. Does that make sense to you? So you have to be very careful. You're going to want to assume things. And I know it's hard not to, especially since you've kind of been trained to, not to do it. Okay. All right. So back to rhombus. So we have this. If a parallelogram is a rhombus, then it's blank. All right. So first of all, we know that this is a parallelogram and it's a rhombus. For a parallelogram, what is true about the diagonals? For a rectangle, they're congruent. For a parallelogram, they bisect each other, right? So this is, and I can't just put one on that because there's already one on the sides. So we get this, right? Now on the rectangle, when you look at the four little triangles, we had two sets of congruent triangles, right? Do I have that here too? Or do I have more than that? They're all four congruent, right? They're all four congruent by what postulator theorem? What's the easiest one to do here? Side, 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 right? All three sides and all four triangles are congruent to each other. So all four little triangles are congruent to each other. Does that make sense? Okay. So if that is true, that means the angles that aren't labeled are all congruent to each other as well, right? So what does that mean the measure of this angle right here has to be? Not 60. Oh, but you do, because it has to be 90, because all four of these are the same, right? You can look at this one of two ways. You can look at it as, you can draw a circle around it, so you can take 316 divided by 4, but you also have a linear pair here. So this has to be 180, and they're congruent, so they're both 90. Does that make sense to you? So all four of them are 90. You only have to label one of them. You can label all of them if you want to, but it gets to be too much. So those have to be right angles every time in a rhombus, right? Because every time in a rhombus, you're going to get diagonals that bisect each other. The reason that that's happening here and it didn't on a regular parallelogram is because now all four of those are congruent. That's what makes all the triangles congruent. So since you get right angles there, how are the diagonals related to each other besides the fact that they bisect each other? What's the perpendicular? Good. So if a parallelogram is a rhombus, then its diagonals are perpendicular. So if it's a rhombus, then the diagonals are perpendicular. So line segment BD is perpendicular to AC. Perpendicular. We good? Questions? All right. So I would like to take all of those labels and put it on this little picture, but I know it'd be way too much because your picture's a whole lot smaller than mine. So we're not going to. We're just going to kind of refer to this picture to get this. So we've got, I know that I've got four little congruent triangles, right? And these are all right angles. And then I know that I can say angle 7 and angle 3 are congruent. Because why? What kind of angle pair is that? Alternate interior angles. So those are alternate interior angles. We know they're congruent, right? Now look at this big triangle ABD right here. Do you see how then I can split it? I can split it into the two smaller triangles here. And this one's just a reflection of that one right there. Yes? Which means these two angles have to be congruent. Okay? And then these are congruent because they're alternate interior angles. Then what we don't have labeled on there, but is true, is that this is all these angles are congruent, and these angles are congruent, which means that the angles that are left all have to be congruent to each other. So what we already knew about a parallelogram is that the opposite angles are congruent, right? For a rhombus, not only are the opposite angles congruent, but the diagonals also bisect those angles. Because these being congruent to each other right here doesn't happen in every parallelogram. Does that make sense to you? Yeah. So it only happens in a rhombus. Yes. So if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Yes. Yes. I can label it. Yes. And you can label it if you want to. It just didn't directly relate to that, so I don't want to confuse anything. But yes, if that helps you. And that's why you know all four of these are congruent. So once you get those, you only have one angle left in each one, then they have to be congruent to each other. We good? So this one, this abbreviation is a little bit longer than the rest. But if it's a rhombus, then the diagonals bisect opposite angles. So we have two sets of four congruent angles. So I can say angle 1 is congruent to angle 2, which is congruent to angle 5, which is congruent to angle 6. And then angle 3 is congruent to angle 4, which is congruent to angle 7, which is congruent to angle 8. Everybody good with all that? All right. So now, next definition. Definition of a square. A square is a quadrilateral with 4 right angles and 4 congruent sides. It's like a combination of the two. So there are not any additional properties here and additional theorems. It just has them all. Okay, it is a rectangle, it is a rhombus, so it has to also be a parallelogram. And everything that applies to all of those also applies here. Okay, so a square has all the properties of parallelograms. It is a super shape. Parallelograms, rectangles, and rhombi. It's not rhombuses, it's rhombi. The rhombi. That's a Roomba, not a Roomba. A marimba is an instrument. Okay, we good? So a square's got it all. All right, so let's look at this example. It says a woodworker constructs a rectangular picture frame, bless you, so that the length of JK is 50 centimeters. The length of JL is 86 centimeters. And I want to find the length of HM, so I'll just call that X. And it says state the theorem that supports your answer. So I want you to think about it for a second. See if you can figure out what the length of HM would be. What's the length of HM? 43. Is that a really difficult question? It's really not. But if all you can do is come up with 43 and that's it, you're not getting any credit at all, okay? Because you've got, centimeters is important too. But the explanation of how you got there is important. So I'm guessing that you took half of 86 to get 43, right? So why do you think it's okay to take half? Because the diagonals bisect each other? Is that a true statement? Yes, okay. So that makes sense, right? Except that you took half of 86, and HM is part of KM, so how did you know you could use 86? Because the diagonals are congruent, right? So you have to be able to justify how you got there. That actually takes 2 theorems to get to the easy answer of 43. It tells me it's a rectangular picture frame, so I know it's a rectangle. And then, so I know that the diagonals have to be congruent. So I can start by saying, well, I know that the length of KM is 86 centimeters. And the reason I know that is because if it is a rectangle, then the diagonals are congruent, right? Then once you have said KM is 86, now you've got that diagonal that you can take half of. You can say HM is 43 centimeters. Now, the fact that the diagonals bisect each other, is that a rectangle property or a parallelogram property? Parallelogram. So I can't start off by saying it's a rectangle. I say if it's a parallelogram, which it is, then the diagonals bisect each other. The explanation, way more important than just the number. Okay? Are we all good on that? Any questions about that? All right, so let's look at this next one. It says ABCD is a rectangle, so good. Again, you got to focus on, okay, I know it's a rectangle, so you know some things going on here. Find each length, state the theorem that supports your answer. All right, so I'm looking for the length of BD. What would the length of BD be? 13, right? It's 13 inches. Then I have to have a theorem that supports my answer. Is that a rectangle property we used or a parallelogram property? Parallelogram. Because if this is 6.5, I know this is, right? And then add them together to get the 13. So if it is a parallelogram, then the diagonals bisect each other. Okay. Everybody good with that? Then the length of CD. What's the length of CD? 5? Do I agree with that? 5 inches. Okay. So, good. Now, earlier today when I did that and we wrote that down, so I said, wait, can we assume that? Okay, here's the difference between assuming. If I can't write a theorem that supports that, then I'm assuming it, right? If I have something to back it up, I'm not assuming anything. Because what you're answering with that justification is how you know that. You know that not because it's a rectangle, but because it's a parallelogram. If it's a parallelogram, then the opposite sides are congruent. Okay. Which makes it true about a rectangle, because a rectangle is a parallelogram. Okay. We're all good with that? Alrighty, so then I'm looking for the length of AC. So what's the length of AC? 13. Okay. And if I didn't already have BD right here, then I'd have to do a couple steps to get there, but since I have that, I'm good. And the fact that I just know it's 13, is that a parallelogram property or a rectangle property? Rectangle. So then I say, if it's a rectangle, then what? Good, the diagonals are congruent. We're on a roll. Then the length of AE. 6.5, yeah. Because we already said that AC was 13, and then we would take half of that, so 6.5 inches. And if it's a parallelogram, the diagonals bisect each other. Okay. Well, because I came about it in different ways. Just because it's the same number doesn't mean I come about it the same way. On BD, I got that it was 13 because if this is 6.5, then this is 2 because the diagonals bisect each other, right? The diagonals bisecting each other is a parallelogram theorem. It's because this is a parallelogram. So after I've said that this is 13, when I get down to AC, I just know that this is 13 because I don't even have a 6.5 to use here. It's 13 because this one is. That's a rectangle property. The diagonals are only congruent if it's a rectangle. But for every single parallelogram, the diagonals bisect each other. Does that make sense? Okay, it's a good question. Anything else? We're good? Okay. All right, we're going to stop here because this is where I've stopped in the other classes. And I'm not giving you the homework. I don't know if I said that earlier. I think it's still said on the calendar, but we're going to finish this up on Wednesday.